choose the watch, that's fine. Okay. All right. I'm not sure exactly where I ended last time. I'm thinking it's right. I started the array. I was talking about character strings was the last subject I talked about. So I may be overlapping a little bit that there. But C uses an array to store strings right there. And you can declare, back when I first started taking C, we didn't use the string type. We used the char type right there. And that was added to a later version of C after I first started. So I sometimes still define a string as an array of characters out there. But if you're going to use strings, normally you would include the string.h because that would then declare that. Now, one of the problems you run into is that if you use a scanf command, and this we'll talk about that in a second, scanf doesn't necessarily limit the number of characters you type in. And if you declare a string as an array of characters, it doesn't necessarily leave room for the end of characters in the string command. So in this particular case, char string 1, and again we have the bracket, open close bracket, to denote that this is an array of characters, and we initialize it to the string first. And strings are denoted with the double quotes around them. A single quote is a char right there. So when we initialize this will set this up that contains 6 characters. So this will dimension the array to 6 characters. The last character is the null character, denoted by the \0 right there. All strings in C end with this character right there. So any array should be large enough to contain that there. So this is what another way of dimensioning, although I don't know of anybody that would type out the single quote in each character at a time, but you can dimension an array of characters like that there. And it just simply says that you can access each character in loops. And in some courses back, when we used to do a lot of string manipulation, and I know people that still do string manipulation as part of their C programming, because a lot of times when you're reading like net lists and things like that and reading them into simulation programs, you have to read the file, each character at a time, and access that there. So you can also use the scanf with the specifier %s right there. So, but notice that when you do that, you have to use a modifier to tell it how large the string is that you're going to input. In this particular case, we dimension the string as 20. So that means that we've got an array of 20 characters. And we're going to read in the first 19 characters that are read in or less into string 2. Anything beyond the 19th character is ignored right there. Because the string is that there, without the preceding is used that there. And also note that I'm not using the ampersand here, as I did in previous cases, because string 2 is an array. And I mentioned earlier that when we pass arrays to functions, the address of the starting point of the array is passed, not the value. And I talked a little bit about value versus reference earlier. So when I send a string to the scanf, I don't need the ampersand right there because it's an array right there. The name of the string is passed without that there. So the 19 is required that the string should be no longer 19, leave room that there. If someone types more than 19 characters and you don't send that %19 %19s, then the scanf doesn't know that, and it's going to overwrite in memory the additional characters. What's after string 2, I don't know what's stored in memory. It could be other data you've got. It could be other program memory. But it's going to write into memory that's not allocated for string 2, data from string 2. So it's going to overwrite in the memory where it shouldn't right there. So it could cause the program to crash, create a security violation. It could cause your system to lock up, or it could do nothing wrong. Or it could work sometimes and then other times crash. This is one of those types of errors that may not be caught the first time debugging, because the way you declare the array, the way that the program loader loads it into the computer, there's nothing after string 2. It's just empty memory. So everything works great. You run the program onto another system that's got less memory, or it's got different programs running in the background, and all of a sudden it crashes something. So, you know, the big thing here is your program may crash or create a security vulnerability. So you use the %19 to specify right there. And again, this just simply says that it's your responsibility to ensure that you don't do that. So now, again, this is printf doesn't matter. Printf doesn't matter. You don't have to tell printf the 19, because the printf will stop printing when it sees the null character. That's when printf. Come on in. I was a few minutes late myself. But printf prints until it sees the null character. And that's the reason for the null character. So, you know, kind of a funny thing that's happened to me where I've made some programming errors is that I've done the scanf without the size of the string. And then I've done some other work and what's after the string f, or the string 2 in memory, can contain something else. And if I overwrite that with something else, the printf will just keep printing until it sees the null character. So you could end up with a page of garbage. You could end up with the thing printing for 5 minutes before it finally hits a 00 in memory. Because what happens is, I don't know why I always want to set my pen, but here's memory right here, and here's string right there. That's an address that's pointing to at there, and that goes down to however many, and we've got, and I'm going to put a bracket 0 here to show that 0. This is string 2 bracket 19 right there. And this is here. And this might be, I don't know, some variable. I'm just going to call it X right there. We don't know what it is. And that's right there. If I overwrite this, then X is overwritten right there. Right there. And of course, anything else if I don't get there. But if I read X in later, X might contain 35, for example. In other words, I've read something from the keyboard and assigned it to X, or X is equal to something, and I've overwrote that. So right there. So, and this could, and the null character might have been there. So if I read in 20 characters, null character, or if the null character happened to have been here, here's my null character, and this is Y, and I read in Y is equal to something, the null character gets wiped out. So the printf will just keep on printing until it sees the null character in that there. So that's why characters and strings are printed until a terminating null character is encountered. So if you don't use the %19s, you run the risk of that null character beat. Because if you read it 23 characters, it's going to make the string 24, so it'll act like string 2 bracket 24 or 23 is the null character. It'll assign the null character to that location, but that location is assigned to something else in memory. That there. So here, for example, size, and this is an example. I'm not going to dwell on here. That there. So here we're just reading the scan in that there. Now, if you type more than 19 characters, it'll just wipe it out right there. So again, here we're here, and again, this actually is using the %C to print out the individual characters one at a time, right there. This one here is doing it with the %def. The string is with spaces between the characters here, right there. So again, this is just an example here where we type in hello, string 2 is string literal, string 1 with spaces right there. So it's the scanf is reading the scan. Printf, the first one is printing it using the %s right there. The second one is that there. The second one is printing it, and notice that we put a space in between each one of those right there. So this is printing out each character one at a time. But if I'm printing out one at a time, we're saying as long as I is less than size and the string I is not equal to the null character. So we're looking for the null character here. So we're essentially replacing the printf %s with, here we're doing a %C, and that's how we would print out individual characters in a string right there. Static arrays, that there is not created, initialized, that there. That's if you have a function in a function. Now I'm not going to cover that right there. So let me skip. Here, when I declare an array as static right here, that means every time I go back to this function, whatever was in the array before is kept. If I don't have the word static, that array is reinitialized right there. So, and that's the same with other variables declared as static inside functions. The word static doesn't mean anything with main, because main is always active in the background. But anytime you have a function and you want to keep the value of any variable in that function same next time the function is called, you have to declare it as static. Then it will remember the value. So in this particular case, here we entering the static automatic array here, and here it reinitialized the value. Here it kept the value right there. Passing arrays to functions, I already mentioned the fact that here we've declared an array. Now the term hours and day is not shown here, but that's a constant declared. Again, we declared constants by keeping them all constant. So we're modifying the array, we're passing in hourly temperatures. We're modifying the array, but we don't have to pass its address. That there. Automatically passes array by reference right there. So if you pass an array to a function, it can change the values of the contents right there. So that there. So again, keep in mind that we can pass the array, or we can pass the address of array bracket 0. right there, and the address of the array there. We're not going to talk too much about the pointer conversion. A %p means the address of, right there, and that's a more advanced subject right there. So again, there. I think I'm near that here. Printf, again, here we're saying that we're going to array equals percent there, and this gets into here. What this is showing is that it's showing the address in memory. It's not actually, the array is defined an array of 5, and what we're printing is %p as the address of array 0, of the first element in array 0, equal %p. Then we're going to pass the array equals %, the address is % that there, or we can pass it the address right there. All three of these say the same thing. Array is a point, we're passing the address of the array. Here we're passing the address of the first element, and here we're also passing the address of the array. The ampersand is not needed. It's the whole key there. The %p is telling that you want to print an address. That there. %p is a data type called for addresses. So where is 003F930? Someplace in the computer memory. We don't know. We don't care. It's a general rule if you're dealing with desktop computing programs, you don't care about physical addresses. When you're dealing with embedded systems, you sometimes care a lot because physical addresses can be the port, the address of various. We don't want to restart now. We're going. My system is doing a backup, doing an update in the background there. So again, I'm not going to dwell too much on these here. The whole key is that when you're dealing with arrays, you don't have to put the ampersand. That's the only thing you have to keep in mind. And when you're dealing with arrays, when you change the contents of an array in a function, it changes it in the main program or the calling program. That there. So be careful when you're dealing with arrays and you change something in the array, it changes everywhere that array is referenced to. So that's just simply, this whole discussion gets into the fact that here, this is a program that we initialize an array. Did we initialize? Oh, okay. We define an array as 0, 1, 2, 3, 4, right there. We print out the array one element at a time, right there. It's integer. We output that. We modify the array and we print it out again, right there. And notice that when we modified it, we changed the contents of the array is the only thing right there. And constants, I've never used it, but you can use the constant right there. Shows an error message that there. You usually can't do that right there. If I pass an array with a constant identifier and I try to change it, the array doesn't work. It will not work right there. So, okay, sorting arrays is a very interesting topic. There's plenty of reasons you would want to sort arrays right there. And chapter 12 gets into it in great detail. Obviously, we're not going to get into chapter 12, but typically when you want to sort an array, the simplest one is something called a bubble sort. And all you do is you swap two values, and you go through the array a number of times until you get the the lowest value on top and the highest value at the bottom, or vice versa, right there. And there's lots of different algorithms for sorting. Bubble sort is probably one of the least effective but the easiest to understand. Each pass, two are compared, and if you go through it enough, you'll end up with the array sorted. So we started out right there. We enter the array. Here, it's actually entered. It's not sorted, original order. So we print the array, and we go through this loop here. And it's two loops. And all we're doing is we just simply go through the loop a number of times right there. And we go through the loop from pass is equal to 1 to pass is less than size. And then we go from 0 to size minus 1 again. So it's an n-bit. So we're going to go through n squared times roughly. So if our array's on 10 elements, we're going to have to do 100 comparisons. If our array's 100, we'll have to do 10,000 comparisons. So it's a fairly, and all we do is we just swap the two right there. Now, there's lots of reasons we'll want to sort arrays. For example, if we want to read in a bunch of data and look for a particular piece of data, it's best if we sort the array before we do that. This is one of these topics that I could spend 3 weeks on just sorting arrays, and then after we talk about structures, how we sort structures, and then how we search for things. But normally, if an array is sorted, it's easier to search through the array. That's the reason we would do that. This just basically gives an example of how we would sort an array. I'm not going to that there. But this goes into more detail. I'm going to skip over this. Sorting arrays up there. There isn't a swap command, so we have to set up a temporary variable and just up there. Sorting arrays, it goes in that there. Virtue, it's easy to program. It runs very slowly, right there. Far more efficient sorts of Oct. I've already mentioned the fact that the bubble sort is when you talk about algorithm complexity, and that's the way computer science people talk about it, the way that I learned it, it's an n squared algorithm, which means that you double the number of elements in the array, you've made the algorithm 4 times slower. So it's a very inefficient sorting algorithm, but it's a very easy one to write. That's why they talk about it there. And I'm going to, as I said, I'm going to kind of finish up this chapter and then right here. And sorting, and this is an example where they go through and they read in a bunch of data, and they have 3 functions to look at: the mean, the median, and the mode. The mean is, of course, the average. The median is the value which half the values are above it, half the values are below. The median and the mean don't mean the same thing. So if I surveyed this room and I asked, say I have 10 people in this room, and I asked everybody their salary, 3 people said 5,000, 2 people said 6,000, 3 people said 4,000, and 1 person said 100,000. The mean is very greatly skewed by that 100,000, right? Now all of a sudden I've got a mean value, and I'm just making numbers up, of 13,000, 14,000. But that doesn't mean the average person in this room is making 13 or 14,000. It means the average in this room is. So the average is not, but the median means that half the people above that and half the people below are making that. And that might be 4,000, it might be 5,000 in the numbers I gave you. And the mode is the value that has the most. So let's say 4 people out of 10 are making 4,000 right there. that might be our mode. So when we look at here, mean that there, and they don't define mean, mode, and median. I was looking for their definition right there. The mean is the average value, blah, 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 divided at there. And we just sum everything up, and it's the total divided by size right there. The bubble, we use the bubble sort to find the median, and that's the middle unit in our array right there. And then to find the mode, we have to look for use of frequencies. In other words, what's that there? And that represents the largest right there. So again, those are here, and it's easier to calculate the mean, the mean, or the mode, and the median if the array is sorted right there. So again, we're going to here. The mean value is 6.87, the unsorted. The median is 49, right there, and right there. And it says that the number 7 came up the most, right there. The median is value right there. Mode occurs most frequency. So that's an example. Not one that you're probably going to run across, but the statistics people run into that a lot. Searching arrays, right there again. I'm not going to go into this great detail, but if I want to search an array for a particular value, it's much more efficient to search an array that's been sorted, because I can use what's called a binary search. I can look in the middle and then determine whether or not it's in the top half. If it's the top half, then I can look at 1/4 of the way through, and I can narrow down much quicker than I can going through each number one at a time, right there. So, but there, again, I'm not going to go into that in great detail, but there, by a linear search, we go through the array one element at a time until we find what we're looking for. On average, that's going to be n divided by 2. I have 100 elements in my array, and I'm looking for a particular name in that array. That there, half the time, you know, if I did search for 100 names, it's going to take me on average 50 times to find the name I'm looking for, right there. If the array is sorted and I do a binary search, I can usually find it in 2 times the log of 2 times log 2 of n. So in other words, it might take me the average of about 5 times to find the name right there. And you know, an example of that would be I got guess a number between 0 and 100. We'll go from 1 to 100. Take a guess what that number is. I'm just going to put a number down, 35. So we don't have to guess it. Now, if I go through this array and I guess, all right, is it number 1? Is it number 2? Is it number 3? Is it number 4? It's going to take me 35 times to try that, right? But if I guess first 50 and I say, no, that's too high, I guess next 25. Well, that's too low. So I now know it's between 25 and 50. So now I'm going to guess between 25 and 50 is 25. So I add 12 or 13 to it. So we're going to say 37. Well, okay, that's still too high. So now it's between 35, 37. And eventually I'm going to get on 35 right there. And I'm not going to go through every step to get to 35. But it's going to take me a lot less than 35 tries. And that's what a binary search does. But binary searches only work if the array is sorted. So the question comes in is, you know, and again, this depends on the program you're writing, and it's beyond the scope of this class. But if I've got 10,000 employees that's sorted by IC numbers. We'll use IC numbers right there, and I don't know how IC numbers work. I don't have one, but I think they start with a year, right? So everybody's born in 1985. Then you're born in a particular state, so we're going to say 15 for whatever state number it is that there, and then it might be the 256th birth of that there. It's some kind of scheme like that, right? That there. Again, so if I want to search by you know, if I want to find one of my 10,000 employees very quickly, it would be best if I sort the array of employees by IC number, and then I put in the IC number, and I pick the middle value. And then it's in the top half of the array, and I narrow down. Otherwise, I'm going to have to do 5,000 comparisons on average before I find that employee. So it's best if I sort the array, array first. Now, later on, you'll find that we can do things such as binary trees, where we can add new elements to the tree where it's already sorted. We can print out a tree and search a tree. But binary trees are actually much more efficient, but way beyond the scope of this class. That there, and we can actually save the array in binary, in sorted form. So it's already sorted when we save it to a file. So the file itself is sorted. But the whole key thing that we're looking at here is that a linear search goes through one employee at a time. A binary search and again the average is, is half the time it's going to find, it's going to take half the time. So my example of 10,000 employees, it's going to take typically every time I want to search for a particular employee, I have to go through 5,000 records before I find that employee. If the array is sorted by IC number, then I'll only go through maybe 50 employees before I find the right one. Much quicker, much quicker. And again, for the type, the size data that we're working on in this class and the size of the arrays that we deal with here, you wouldn't see a huge amount of difference. But if you're the tax department and you're trying to find a particular citizen's number to figure out how much tax they owe, when you go in there that makes a huge difference when you're going through 25 million citizens and trying to find a particular person's tax record. So typically, this is linear search. Then they go through and they do the binary search, and I'm not going to go through. They got a lot of stuff on there, but again, the key thing is loop until the low index is greater than the high, and they go through and keep dividing it by 2 until they get to the right one right there. And again, it goes back to my example. Pick a number between 1 and 100. You start with 50. All right, is 50 too high or too low? All right, if it's too low, then you go to 75. If 75 is too high, then you go to 63 or 62 at 62 or 63. All right, if that's too low, then you go to 69 or 70 right there. And then you find it within 4 or 5 tries right there. Or if you went through between 0 and 62 or 65 or whatever number it is, it's going to take you on average 50 tries to find the right number. So, and of course you got the return not negative or -1 saying that we didn't find it right there. It's not in the array. And this is a large program that goes through that there. Again, I'm skipping through this topic because it's not one that I expect you to be able to do, but you've heard of it at one point. You know what's meant by a binary search. You know what's meant by sorting an array. But if you ever have to do it in real life, you'll probably have to look it up in a book or on the internet. But again, the key thing is if you're going to be doing a lot of searches on data, It's much better to sort the array first and then do binary searches. If you're only going to do one or two searches, then it probably wouldn't pay to sort the array. Okay, I mentioned multi-dimensional arrays, and this is a confusing topic, and it'll be the last topic I'll talk about today, right there, and we'll probably come back and revisit it, after the break, since we're going to be a full week before we visit that there, and I'll probably have a small assignment for you on that there. Actually, I'll probably cover chapter 7 and then give you a final assignment on C. But arrays that require two indexes are two-dimensional arrays, right there. And we'll see what example he has that there can have two indexes. They're broken into rows and columns, or a matrix, right there. And most of you have seen what a two-dimensional array looks like by looking at an Excel spreadsheet. Excel spreadsheets have columns and they have rows. So you have a cell in there called A3. So A3 is in the first column and it's in the third row, right there. And that's similar to the way we look at how things are done with a multi-dimensional array in C, right there. Now, when we look at this here, and we'll be doing a lot of that when we get MATLAB. MATLAB will just jump right into arrays, two-dimensional arrays, matrices, right? But here we have the address. We don't have A, B, and C in Excel. And where is my mouse? It doesn't see my mouse. All right, okay. Right here. All right, I don't know what's going on here. I'll just turn off my mouse and use my touch. The columns are not labeled A, B, and C. They're labeled 0, 1, 2, and 3. So that's a little different than Excel. Right there. There are rows that there. So our first element here is the row number, then the column number, right there. Again, that's opposite from Excel. Excel, it's usually column row. A1, B1, B2, right, or C2, right there, or right there. So in Excel, this would be column A, B, C, D, right? This would be row. This would be B2. This would be B3, because Excel starts with 1. It doesn't start with 0. C starts with 0. So again, we have two brackets right there. One is for our first one is our row number. Second is our column number right there. And that's how we look at our data being stored. So again, every element is addressed with an element name and a row column number right there. So here we're dimensioning in our two-dimensional array. The first row is 1, 2. The second row is 3, 4. Notice that we have braces to denote between the rows right there. So again, here we're dimensioning. Here we only have one value here. So that's going to set the second value equal to 0. Right there. And that's somewhat confusing because you would think that row 1 would all be 1, but it's going to be 1. If you leave out values, it's going to put a 0 in there. So it's going to be 1, 0, then 3, 4 right there. So here's a two-dimensional array right here. Now here is puts values in array 2 that are row. This is dimensioning array is 2 and 3. Here we're dimensioning in a row right there 2, 3, and that's going to be 6 values. That's going to be a little weird. That's actually sloppy programming. I would not do that there. And here we've got 2, 3, and also notice that we've only given it 2 values here instead of 3. And here we've only given it 1 value right there. And you can see here it puts 0 in the missing values right there. And also notice that our array that we didn't put the braces in, that it did it 1, 2, 3, 4, 5, 6, and it automatically did that. And that's because C the way it really stores the data, let's say I declare an array as 2, 2 right there. It's going to store it a 0, 0, a 0, 1, a 1, 0, and a 1, 1. It stores the data linearly. Right there. It doesn't store it in a two-dimensional array. Memory is not two-dimensional. It's one-dimensional. So what it does is it looks at the size of this right here, the number of columns, and it says this goes to the first row, and then these go to the next row. That there. So it's going to store it all in a linear fashion, and that's why when he does this done here, right here, 1, 2, 3, 4, 5, it's stored at 1, 2, 3, 4, 5. No, the 4 and 5 were in the second row, right there. And that's just because that's the way that C stores the data. It's always stored in a linear fashion. So even though we treat it as a two-dimensional array, and we can process it as a two-dimensional array, it's actually stored as a one-dimensional array, right there. And that's why this trick here works. I consider it sloppy programming, and I don't think it works in MATLAB. It might, but I don't think it works in MATLAB. MATLAB, I think that personally, I think that should give you an error. I see this is the correct way of doing it if you're going to initialize the array. Right there. The second way is okay, but again, we're augmenting it with zeros. Right there. So again, it goes through the various discussions that the initializer is assigned to the first row, then the second row, right there. Any elements that are initialized are initialized as zeros, right there. There. So again, many common array that typically we will use nested for next loop statements when we're dealing with arrays. He doesn't talk about that here, but here we're initializing right there. This is the most common. Here is way we're going to go from the number of rows to the number of columns right there, and we're going to total up everything in the array one row at a time. This is the typical way we process arrays with there. And I think I'm going to wrap up. 2 reasons. One is I think I'm looking around the room and I'm seeing some people that are glazing over a little bit. This topic is kind of at there. And 2, I'm starting to glaze over that there. So I'm going to wrap up at this point. Yeah, it's a little shorter than normal, but at there. These topics are I went very fast through a lot of these topics. Again, I'm not really going for deep understanding on these. I'm going for more for two-dimensional arrays. Will go a little deeper once we get into MATLAB. So it's important that but you'll see them again. But I'm going to